Hi, welcome back. We are still on Unit 11, Day 2, Independent and Dependent Probabilities. And we've talked about how to find the probability of an event happening. We're going to put our favorable number of outcomes over our total. Then we're going to reduce that fraction, and we can now also change it to a percent. Okay? All right, so now we're going to talk about what happens when we have a compound event. That is two or more things happening together. Those events can be independent or dependent. If they're independent, their outcomes do not affect each other. If they're dependent, the outcome of the first event affects the outcome of the next event. Okay? So for example, if I roll a number cubed twice, what I get the first time I roll has no impact on what I get the second time I roll. So those would be independent events. Rolling a die 2 times would be independent, or rolling a pair of dice, what I get on each die would be independent because one die does not affect the other. However, if I pull out 2 marbles of a bag and I keep them both times, that is going to change my probability because when I pull that first marble and hold on to it, then when I go to pull the second marble, it's going to affect the total number of marbles that are in the bag. So it's going to affect the percentage or the probability for the second marble pull. Okay, so that would be considered a dependent event. Okay, let's look at these examples and determine whether or not they are independent or dependent events. Okay, so the first one, rolling 2 die. I already mentioned that one, right? If we're rolling 2 die, whatever I get on the first die has no bearing on what I get on the second. So that is an independent event. If I draw 2 cards from a deck of cards, when I pull that first one, there's 52 cards in the deck. So if I've pulled 1 card, now there's only 51 cards in the deck, so it is going to change my probability for the second pull. So that is dependent on what I get on the first one. Number 3, drawing a card from a deck and then tossing a coin. The card will have no bearing on the probability of getting either tails on a coin or heads on a coin. So that is going to be independent. And then cracking an egg from a carton to see if it has confetti. So if you have a bunch of confetti eggs and some of them, let's say, are defective and for some reason don't have confetti in them, right? That's going to be, so when I crack the first egg, well, now there's less eggs in the carton, right? If I start with a standard carton of 12, when I open the first one and see it does or does not have confetti in it, then the next egg I take, well, there's less eggs to choose from now. So my total has changed, which means it's going to be dependent. Okay? Let's look at actually finding some of these compound probabilities. To find compound probability, you're going to multiply. Let me get a different color here. You're going to multiply the probability of each event to each other. Okay, so you're going to find each probability and then multiply them together. So let's look at doing that. All right, so find the following probabilities for spinning the spinner and then tossing the die. Okay, so I've got this spinner and I'm going to spin it, and then I've got this die. My first one says, what's the probability of landing on red? Okay, so red, I'm actually going to use a little color. So here's my red, okay, and I can see that there is one wedge on this spinner that is red. So there's one red outcome out of how many total? Now it's kind of tempting to say there's 1, 2, 3, 4, 5 sections, but this green section is a lot bigger than these other 4 sections. So you have a bigger chance of landing on this than you do, say, blue or red or black or this green, right? So I need to make sure that I'm thinking of this green as being really not just one green section, but there's 4 on top, which means there should be 4 on the bottom. So there's really 4 green sections on the bottom, 1 green section here in case we ever are looking at green. Okay, so my total number of even sections or the congruent sections on this spinner is really 1, 2, 3, 4, 5, 6, 7, 8. So 1 out of 8 is my probability that I will land on red if I spin a spinner on this wheel. Okay. Then I want the probability that I will land on 3. Well, on my die, there's only 1 3, and there's 6 sides. So my total probability, when I multiply those together, is going to be 1 times 1 and 8 times 6. Use your calculator if you want to. And then you can reduce that if it reduces. 1 out of 48 doesn't reduce. It is what it is. 1 out of 48. Okay. And you can leave it like this, or if you want, you can change it to a percentage by saying math, change that to a decimal, and then multiply it by 100. And it's 2.083%. Okay, so a very low percentage for landing on red and rolling a 3. Landing on red and rolling a 3. Okay, all right, the next one we're going to look at is the probability of landing on blue and then getting an even number on my number cube. Okay, so there is 1 blue section on my spinner board or my wheel. So 1 out of, there's still 8 on here, then times on my die, we've already looked at even. We know it reduces to 1/2, but even if you don't want to reduce it, you don't have to. You can wait till the end to reduce. I know there are 2, 4, and 6 that are all even. So there's 3 numbers that are even out of 6 numbers total. So 1 times 3 and 8 times 6. 3 divided by 48 as a fraction. 48 as a fraction. Math. Number 1, enter, is 1/16. If I want that as a percentage, I'm going to say math, change that to a decimal, and then multiply it by 100 to move my decimal over 2 places, and it is 6.25%. So again, not a very good percentage, not very good probability or chances that I will get a blue and an even number. It definitely can happen, just not super likely. Okay, all right, and then the last one here, let's look at green. For green, there are 1, 2, 3, 4, 5 green places. And then I wrote 3. 5 green sections on that wheel out of 8 total sections. A real number is anything that's not like an imaginary number. Remember from Algebra 2 when we tried to take a square root of a negative number and we'd have to put those little eyes? So real numbers are going to be any integers or whole numbers or rational numbers. Those are all real numbers. So all 6, 1, 2, 3, 4, 5, and 6, those are all real numbers. So there's 6 real numbers on the die out of 6 numbers on the die. So definitely I'm going to get a real number, right? It's going to happen. 5 times 6, 8 times 6, and when I reduce that, 30 divided by 48, math, fraction, enter, is 5/8, which makes sense because 6 out of 6 reduces to 1, right? And so 5/8 times 1 is just 5/8. So then we hit math and we say, okay, turn that into a decimal for me. And then we multiply by 100. And it's very much so likely, more than half the time, we should get 62.5% of the time, we should land on green and get some sort of real number on our number cube. We're always going to get a real number on our number cube. Okay? All right, in the next video, we're going to finish out looking at this bag of marbles, and we're going to talk about the difference between with replacement and without replacement and what kind of an impact that can have on probability. So come on back for these last few examples. Thanks so much for watching.